On Friday, February 3rd, our lesson was about angle relationships with circles. And we used rulers, we used protractors to actually prove some theorems that we're going to use on Monday. And so our first angle the first angle that we're dealing with is a central angle, and this is an angle that has the vertex of the angle is at the center of the circle. So it asks you to draw a straight line forming two radii that's endpoints were on tick marks on the circle. So the first thing we did was we drew two radii, and then the second thing we did, we answered number one. We used a protractor and we measured that angle to be 120 degrees. So we put that here. Then we determined that each tick mark around the circle is 10 degrees by knowing that the whole circle measure is 360 degrees, and there were 36 tick marks, so each one is 10. Now I counted the number of tick marks here, and it was 12 tick marks. So 12 times 10 is 120 degrees. And comparing the two, we figured out that the measure of the central angle is equal to the measure of its intercepted arc. You can pause this if you want to go through it yourself. Now, the second one that we worked on Friday, I'm going to go to a different packet, was one that has an inscribed angle. An inscribed angle has a vertex on the circle. So here, it asks you to draw two chords that have a common vertex, and they intersect, again, the circle at tick marks. So I measured the degree of the angle. It was 20 degrees. Using our protractor, you line up the vertex and then line up the edge, and it's 20 degrees. And then I counted the number of tick marks, and it's 40. So my measure of my intercepted arc is 40 degrees. And I looked to see what the relationship was between the intercepted arc and the degrees, and we determined that the inscribed angle is half of the intercepted arc, or the intercepted arc is twice the inscribed angle. So that was kind of what we found there. Moving on along to the third circle that we dealt with, it asked you to draw a chord and then a tangent line that intersects with the chord at a vertex on the circle. And we determined that this one, it was a little bit more difficult to work with because we had to draw like a true tangent line, or else our measurements would be a little bit off. And so in this case, we measured our angle to be 125 degrees. So I have a tangent line and a chord intersecting at point H. Now, when I counted the number of tick marks of the intercepted arc, and that intercepted arc, because I'm dealing with this angle, is this arc right here, there were 25 tick marks, so that was 250 degrees. And so the relationship, again, because the vertex is on the circle, is the angle measure is half of the intercepted arc, and this is just an arc, or the measure of the arc is twice the angle. Moving on along to the next one, we had a vertex that was outside the circle. We were given a secant, and we drew another secant that intersected the first secant outside the circle. And what we determined is that we come up with this angle right here that is formed, and this time we have two intercepted arcs. So I used my protractor, I measured the intercepted angle, it was 35 degrees. Or not the intercepted angle, I measured the angle, it was 35 degrees. Then I measured the arc that was formed, the larger arc that was formed, intercepted arc that was formed, and then I had the smaller intercepted arc and tried to find the relationship between the two. And the relationship between the two was the angle formed by the intercepting secants with a vertex outside the circle is half of the difference of the two arcs formed by the angle. So the measure of the angle is equal to the large arc minus the small arc divided by 2. So this is when the vertex is outside the circle. And then moving on along to the next page, we had two tangents that intersected outside the circle. And again, we used this is a very special case because in this case, the whole entire circle is used. So the larger circle and the larger intercepted arc, plus the smaller intercepted arc is going to be 360. But it's outside the circle, the point of intersection. So I used the protractor to measure. It was 80 degrees. I counted my tick marks. It was 26. So 26 times 10 is 260. I counted the tick marks in here. It was 10. So I multiplied that by 10. So it's 100. And I determined to come up with 80. It was, because it's outside again, I can take the difference of my two intercepted arcs and divide it by 2, and it's equal to 80. Now sometimes I'm not given tick marks, but I'm given that this is 260, so I have to figure out this by using 360 minus 260 is 100, and then I subtract the 2 and divide by 2 to find the angle. So then we have another situation where we have the vertex outside the circle, and it's a secant and a tangent. So it would look like this. And this is on page 12 in your packet. And we measured this angle, and it was 80 degrees. We counted the tick marks. There's 20, so that's 200 degrees is my larger intercepted arc. And then my smaller intercepted arc was 40 degrees. So again, it's outside the circle, so I take the 2 and I subtract them, take the difference, minus 40, divided by 2 is 160, divided by 2 is 80 degrees. Moving on along to the next one. Oh, well, that's all of them, except for there was one that we didn't cover, and that was where we had two intersecting chords inside the circle. And in this case, it forms two intercepted arcs. Now notice the vertex is inside the circle. Two arcs inside the circle. And when I'm talking about the two arcs, I'm talking about the two arcs of the vertical angles that are formed. So if I'm looking for angle A, I'm going to look for the vertical angle intercepted arc. So here I can see it's 60 degrees plus 60 degrees, and I divide it by 2, and so that's 60 degrees, 120 divided by 60. Now looking at angle B is a little bit different, because when I count this, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 90 degrees, my intercepted arc. When I count down here, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 tick marks. So that's 150 degrees. And so when I add 90 plus 150 and divide it by 2, it's 120. Now I also know it's 120 because this forms a supplementary angle. It's a line. So we talked about vertex at the center, vertex on, and vertex outside, and then the vertex inside that is not the center. And we'll review these on Monday.